Hi, everyone. So this talk is about a topic on which I'm not an expert at yet. And so because I didn't delve into this topic for many years, I tried consulting with the new AI on the topic. And unfortunately, Grok found only one lousy researcher who spoke of this matter. I hid a picture of the researcher just not to offend myself too much. So let me introduce the argument or the main. This is basically the main slide I want to push, and my role is to give some counter-conventional wisdom argument about the relationship between the following two categories. So if you're not too new to crypto, then you are familiar with roll-ups, zero-knowledge roll-ups. There are the top players in the game, the top builders, Starknet, Arbitrum, which is an optimistic roll-up, ZK Sync, and others. This is known as a maybe layer two component of Ethereum ecosystem and others. And this seems like very different, very distinct from a different set of products or layers, the Oracle networks. In this arena, you can find the Chainlink, UMA, Pith network. These are seemingly very different categories. The category of rollups is about taking the transactions on chain. Let's say we focus on based rollups. It's taking the transactions on chain and saving all of us the need to compute them and only provide us an attestation on the output. So if you consider a based rollup, a zero-knowledge based rollup on Ethereum, for instance, then there's no disagreement, there's no ambiguity as to the input for this for the VM or the contract. You can all go on chain to Etherscan, view the transactions, and compute yourselves the state of the contract. However, rollups save us this need by posting on chain a commitment, a hash commitment, and a proof that they have computed the output correctly. And this is important because rollups are primarily for output integrity. They prove to us that the VM state is what they say it is. On a different side of the spectrum, there's the Oracle networks, which seemingly solve a uniquely different challenge, which is when you want to connect a blockchain to the external world, say to price feeds, to prediction market that lives off-chain in another network, you need oracles to provide that data. And the problem with the challenge with oracles is what I argue here is much more difficult to solve than the problem that zero-knowledge rollups solve. And the reason is that you can't prove that an oracle has misreported. So with zero knowledge, which is voodoo math and cryptography, it's easy to see if an operator of a rollup has posted a false proof. You simply compute the state by yourself and see that the final hash is different than what the rollup operator or prover posted. In Oracle networks, however, if an oracle posts a stale price, either by orders of minutes or seconds, you have no way to refute that price. There are some techniques where you can show that you posted a more updated price. If, say, there's a combination of either digital signatures or ZK TLS, there are protocols where you can show that you posted a more updated price. But still, no one can prove that your price is the most updated price. And no one can refute other oracles' reports. Now, in order to have a holistic network, a holistic integrity network, you can't overlook the Oracle problem, because regardless of how much zero-knowledge proofs or validity proofs you provide to the network, you are still bounded by the trust you put and by the mechanism of the Oracle network. So consider a faulty, a rogue Oracle, as in the tweet of Zach. An Oracle network tinkers, deliberately or not, with the price in order to manipulate the market. It's difficult to prove that, because the Oracle can always deny malice and say, well, I posted a price that was correct a few seconds ago, a few minutes ago, and there was some latency problems, right? There's no cryptographic way to prove that the Oracle has manipulated the price. So in that sense, you can argue, and I admit I'm still manning an argument here, primarily because there aren't, it's kind of overlooked. Not many people are giving enough attention to this aspect, that the argument that I'm still manning is that you should be placed at least as much attention to the Oracle problem than to zero-knowledge rollups or output integrity. So you can think of it as input integrity and output integrity. I will lay out 4 arguments. Some of them I firmly stand behind. Some of them, it's a more thought-provoking argument. But if I'm wrong on one of them, on one or more of them, then I think it's still a good discussion to understand, or a good challenge to understand why I'm wrong about it. So to get a bit more concrete, you can consider a contract from Aave, the DeFi lending protocol. So in Aave, you need to know the contract, the variables of the contract, which are on-chain, need to know how much DAI the user has borrowed. They need to know what's the ETH collateral, wrapped ETH collateral that the user has deposited. And they need to use an external input from an Oracle in order to understand whether the user's collateral suffices to meet that, to secure that loan. Now you can run Aave on a zero-knowledge rollup, or on Validium, and receive a proof that its state was computed correctly, but you're still bounded by your trust of the Oracle. So if the Oracle here misreports, intentionally or not, the price of WETH, then it can cause liquidation, forceful liquidation on the user, an unjustified one, and no cryptographic proof would be able to refute that. So in a sense, the whole DeFi market, because Aave and other DeFi lending protocols are a major building block in DeFi, the DeFi ecosystem hinges on oracles much more, or not less than it hinges on zero-knowledge proofs or validity proofs on layer 2s. Now, the reason I am proposing the argument that this is more important is precisely because there's a deniability. Rogue players in the Oracle game can deny their malice, and there's no way to refute that. Whereas if a roll-up operator, again, will post a false proof, everyone will see it and will lose trust in that layer 2 or roll-up. OK, what does any of this have to do with Caspa? So a bit of context, Caspa is a block DAG, is a proof-of-work governed block DAG. It was originated based on my PhD thesis, together with my advisor, Aviv Zohar, my advisor on the PhD. The whole block DAG paradigm was incepted back then in the Hebrew University. And after a few years, me and other researchers and devs founded Caspa. And now you can see the current state of the network, which is in a few weeks will transition to 10 blocks per second. Caspa is based on a clean proof of work model. There are no tricks, there are no super nodes. Most of your questions about Caspa should be answered in your mind. This is just the same model as Bitcoin. Proof of work, mining, difficulty adjustment, transaction fees, blocks. Yes, it's more complicated because every block points at several predecessors, but other than that complication, which of course requires years of R&D to fit, for everything to fit together, other than that modification, Caspa works very similarly to Bitcoin and tries to remain faithful to the design principles of Bitcoin. Okay, so it started with 1 block per second. Now we are transitioning to 10 blocks per second. And why is this, or how is this related to the problem of oracles? And it requires a bit of inspiration, but once you get it, you get it. The point is that so perhaps zooming back or going back to the familiar Oracle networks, UMA, Chainlink, Pith network, these all have mechanisms which are based on incentives, reputation, etc., to try to guarantee the correct or honest operation of oracles. Without getting too much into the details of these networks, they all have many assumptions around what incentivizes oracles, what deters misreports. My argument in this, about the connection between DAGs and oracles is as follows. If you want the oracle mechanism to finalize in real time, you have to ensure that all oracle reports are posted on your layer without trusting any single entity, not a single operator, not a single miner, not a single consensus leader. Most consensus constructions are based on leaders. For instance, in Ethereum, you have a block, miner or proposer, it doesn't matter the category, but you have a block created by one leader every 12 seconds. In order to ensure that the oracle, so if you trust the mechanism of an oracle integrated or Chainlink integrated into Ethereum, you are essentially trusting not only the tokenomics or the crypto economics of Chainlink, you're also trusting the miner, the proposer in Ethereum to post the oracle's price, and the proposer can manipulate this and decide to either censor the oracle or post a price of a different oracle. And this is a problem that is shared across basically all constructions. The only way you can guarantee that your oracle network has enough attestations and there's no censorship in the same round in real time is by using many proposers or many miners, in the case of proof of work, many miners in the same consensus round. Otherwise, you must trust the miner, and you give authority or power, rather, to the miner to manipulate the price and the oracle feed. What does that mean practically? It means that 10 block per second Caspa can, combined with the correct mechanism design for an oracle network, can solve the problem by allowing multiple attestations in real time. This is very important, in real time, to be brought on chain, and then you have to and you have to combine this with the correct mechanism design to ensure that what's the correct way to average out these attestations and ensure that you're eliminating outliers, you're penalizing outliers, and you are posting the right price to the chain. I'll finish with that. Perhaps I will just say this is an ongoing research together with Elliot, student alumni from ETHA in Zurich, and work in progress. And I hope I hoped I have been successful in steelmanning an argument and triggering more discussion. The lack of a formal model in the academia for this problem. I laid out here a few problems. A few question marks. I won't get into them now because I ran out of time. But in general, I would say the lack of a formal model from the academia and academic research impacts the industry too. This is not merely for nerds. This impacts the whole dynamic of how Oracle networks are positioned in the crypto industry. Like if you go to a VC, if you need to raise money for a VC, you can't really pitch a model. You have to pitch product delivery. You have to understand finance, but there's sort of a lack of fundamental and first principle thinking. And that's why Elliot and me are investing time in this. And I hope to bring you good news in the next time I'm visiting here. Thanks a lot for having me. And it's a refreshing visit since my previous visit in Hong Kong in scaling Bitcoin 2016. It's kind of a different atmosphere, a big shift. Nonetheless, exciting. Thanks for having me.